corresponding thing is P equals to I alpha. This is angular acceleration. In this case, it's also 0. When we have all zeros, this is static. Okay? When they are not equals to 0, it's dynamics. Okay, and sometimes we are not going to talk about just those two things. Sometimes we're not interested the whole system is working or not. Sometimes we're interested if you apply force here, here, and here. And of course we know this thing is not going to move because we know statics. But whether this part is going to be break or is too much force, the material can sustain. So this is going to be in chapter 7. We're going to talk about internal forces. Okay? And still, everything needs to equals to 0. But if you need to discuss whether the material is strong enough to support the forces you apply to it, that is going to be mechanics of materials. That is going to be MAE 43. Okay. Among those three courses, this one, personally, I feel this is the easiest one. This one, you're going to encounter a lot of rotations, a lot of force not equals to 0, so it's going to move, and it's going to move linearly, it's going to rotate, and everything. So this one is going to be somewhat tedious. And based on the student's response, the professor teaching this course, you know who he is, and it's going to be a little bit stressed when you are taking the course. Okay, and this course, some people like this, some people hate this. Personally, I don't like this course, but a lot of students feel this part is very interesting, and in the end of their study as undergraduates, as their undergraduate study over here, they try to do graduate study in material. That's also a very hot area in mechanical engineering. Okay, but essentially, when we are talking about mechanics, those three courses are something we're talking about. Okay, and everything we talk about in this course are based on Newton's law. Okay. First law is that a particle remains at rest continuously to move along a straight line with constant velocity if the force acting on it is 0. Okay, we're not going to use this one. This is in MA 242. Second law, if a force acting on the particle is not 0, the particle accelerates in the direction of the force. And the magnitude of acceleration is proportional to the magnitude of the force. Well, we use part of this thing, but we only use F equals to 0. So when we are talking about F equals to 0, we're actually talking about a few things. One is we decouple that into X, Y, and Z. 3 S's. And all the forces, total forces along all the S's must equals to 0. Okay? Third law, the force acting and reaction between their active bodies always have the same magnitude and opposite directions. We're going to use this one in chapter 5 and chapter 6, and I think part in chapter 7 and 8. We're going to use this one. So third law is a lot of things we're going to talk about. In particular, when we are talking about frictions, that is something use third law a lot. Okay, I'm going to explain this thing in detail when we are talking about those two parts of the class. Okay. So let's talk about force a little. So when I put something over here on the table, so this one is 10 kilograms. Wow. When I'm not doing anything, I just put this object on the table over here. Do we have forces acting on this object? We do. Even though you're not doing anything, you still have two forces. One is gravity. You guys learned this in physics. So when this one is the force created by gravity, you need to have 10 kilograms multiplied by 9.81 meter per second squared. So it will create 98.1 unit. Keep in mind, the unit is going to be changed. And obviously, when I'm putting this object on top of the table, it's not going to move up and down. Again, we're talking about statics, so nothing is going to move, which means there is another force over here to prevent everything from dropping. So this is created by gravity. This is going to be another force, normal force. That is going to be opposite direction, but the same amount. So everything is not going to move up and down. So that's a basic stuff you need to know. Now, if I have a force applied to here, am I going to move this thing? Depends. Because if this one is perfectly smooth, like ice, you apply a force on top, on the side of this object, of course it's going to start to move. But if the contact surfaces over here is not perfectly smooth, what happens? You're going to have friction. So when you have friction, you need to draw another arrow over here. And say this is friction. This one is friction force. And this is friction. So when we have friction, it's going to be the coefficient multiplied by normal force. This is friction. Okay? So combine everything over here. Then you can start to write down your equation of equilibrium. Equation of equilibrium is something we use in MA 241. If you are using in MA 242, it's equation of motion. But they're talking about the same thing. Either it has acceleration or it doesn't have acceleration. So when we are talking about that, the equation you need to deal with over here are going to have two equations. One is fx equals to e minus mu s n. In this case, equals to what? 0. 0. Be sure you know you put 0 over here. Everything we deal with, every number we deal in this class, all equals to 0. That is the first thing you need to know. If you calculate something and eventually the answer is not 0, you're doing something wrong. Unless I'm telling you whether you're going to move the thing or not. If it's not equals to 0, you're going to move something. If I'm asking you the total force applied to it, and you are not giving me a number which equals to 0, you're doing something wrong. Okay. And y over here is going to be mg n minus mg equals to 0. Okay. Oh, one other thing. Something we're going to this is something we call free body diagram. Keep in mind, you will need to put this thing when you are doing your exam, your homework, your quiz. If you fail to do free body diagram on the paper, if it's required, normally it's going to be 1/3 of the points you need to have in your problem. Okay? Okay. That's something you need to know. Now, other than that, you also need to know how to convert the unit from one thing to the other. For instance, your velocity is 65 mile per hour. You see this in your car all the time. Now, I want you to convert this thing in terms of feet per second. How are you going to do that? Okay, so 65 mph is 65 mile per hour. And we know 1 mile is 5,280 feet. We also know that 1 hour is 3,600 seconds. So if you put your unit like this, what you're going to do? So what do you need? Feet per second. So if you do all the calculation, you're going to find this number equals to 95.33 what? Feet per second. So you're going to encounter a lot of things like this in this class. So be sure you know how to do the conversion. Other than that, you also need to know what is a significant number. So for instance, what is the significance figure of this one? 3. 1, 2, 3. What is the significance figure of this one? 2. So which one has greater accuracy? This one or this one? By definition. This one has greater accuracy because the significance figure is 3. So this is greater accuracy. Okay? Other than that. Chapter 1 is pretty much the things I'm talking about. So you need to know how to do the conversion. So sometimes you might say, okay, I have 60 kilograms per hour. Then I would need to do 60 That's another thing you need to do. Okay? So when you're doing that, you're going to cancel out a lot of things. And the numbers over here. So you know 60 kilometers per hour is actually equals to how many meters per second? That is something you would need to do when you are dealing with some of the problems in this class. Okay? Other than that, there are some basic things you guys still need to know. One is area of circle. That is going to be pi r squared. Or it's going to be 4 pi d squared. This is radius. This is diameter. Area of triangle. stays high. There is something you need to know. There are some other things you guys would need to remember from time to time. And one other important thing is that sometimes when you are doing the calculation, you will need to use radians. Sometimes you need to use degree. Depending on which formula you're using, you will need to adopt the numbers accordingly. If you fail to do that, the number you calculate is going to be wrong. Okay? One of the most important things I would need to emphasize over here. United States is pretty much the only country who's still using English unit. You guys are aware of that, right? And in your textbook, you're going to find there are a lot of different things, different unit, metric unit and English unit. Be sure you are using the same unit. Means that when you say you have, I'm giving you 1,000 feet. I ask you to convert that into miles. You need to divide the number by 5,280 in order to get the unit equals to mile. If I'm telling you it's going to be 100 meter and I ask you to convert that into kilometer, how much you need to divide as a metric unit? 1,000. Okay? So those things are different. When you are solving the problem, be sure you always remember which unit you're using. The most common mistake you guys is going to do is what? Okay. So if I'm giving you 32 pounds, is this a mass or is a force? How many say it's a mass? How many say it's a force? This is a force. Okay? So we know what is G. This question is tricky. What is G? Give me a number. 9.81. Okay, what unit you're talking about? Measure. If it's English unit, how much is that? 32.2. Very good. So, this is the first question. Second question. I'm giving you 10 kilograms. I want to know the weight. What do I need to do? 10 multiplied by 9.81. So you get 98.1 Newton. Anybody has problem with that? No. Okay, very good. Now, I'm giving you the weight is going to be 32 pounds. What is the force of this one? Do you need to multiply 32 by 32.2 again? Or this is the force already? How many of you say you need to multiply the number by 32.2 again? Raise your hand. How many of you say 32 is a force already? Raise your hand. Very good. I can also tell you, in my teaching career, 8 years? Yeah, 8 years. Every time I put this kind of problem in quiz, in exams, no matter how many times I emphasize that, 32 pounds. When you are solving the problem, I'm going to see some people 32 multiplied by 9.81. No matter how many times I emphasize, be sure you are not the one making the same problem, making the same mistake I'm talking about here. Okay? And I can also tell you, the percentage of the mistake is not low. It's greater than 10%. So I'm saying this kind of things over here. So if I give you an exam tomorrow, at least 5 to 10 of you guys is going to make the same mistake, even though I emphasize that. Okay? So be sure, when you are dealing with that, pounds is a force already. don't never multiply that by 9.81. For some reason, you guys like 9.81 instead of 32.2, but anyway. And when I'm asking mass, you need to use this number divided by this gravity, so you get the mass. What is the mass of what is the unit of mass in English unit?
Slugs.
Very good. It's a slug. S-L-U-G. Okay. Normally, I'm not going to ask you guys to give me the number of slug, but a lot of time when I'm asking you the force, be sure when you see pounds, leave it alone. Don't try to multiply this number by another gravity again, because again, this is the most common mistake you guys is going to make in the exam. Any question? No? I missed it. You guys need a break or something? Okay, I'll give you guys a 4 minutes break. If you guys need to use the restroom, let's go.